Well, thanks so much to the organising committee for the invitation to speak tonight. I've been trying to think about jokes about being last in the Valley of Death, but I'll need Ian Barr to do that for me. Yes, I have a background in the pharmaceutical industry of about 20 years. I worked for GSK, for Sanofi, and then for MedImmune and AstraZeneca in Europe. And then I'm the co-founder of BioIntellect, and we work on commercialisation of life science technologies. And we really work right from when things are trying to spin out of university all through the value chain until they're in the market. So I'm going to talk to you a bit today about vaccines and infectious disease innovation and how we're going to do, we've got some new initiatives to try and bridge the valley of death. So the learning objectives for this talk, I'm going to show you a little bit about historical and current trends in infectious disease innovation, both in Australia and globally. We're going to talk about some of the barriers to translation and commercialisation and the need for new coordinated pathways. And then I'm going to tell you about BioIntellect Venture, which is a new nationally funded incubator that's going to support infectious disease innovation. And the previous speakers tonight have done a great job in setting context for me. But if we think globally, we've actually got 34 unique vaccines for unique different pathogens globally in the world, and there are 31 pathogens for which there are no vaccines identified, or there are in fact improved vaccines needed. And as you would know, many of these diseases disproportionately affect low and middle income countries. So it's great having had these talks earlier tonight to set up the context for why innovation is needed and what an important role Australia can play. So what do we mean by the valley of death? Well, one of the biggest challenges in commercialisation of any health technology is the mismatch of when things are trying to translate out of academia typically and research institutes, but also industry. New innovations can fail because they can't access enough capital, enough expertise, and they don't have the right structure and funding to survive. And if you look along the middle of that slide, you see the typical pharmaceutical development pathway from basic research all the way through into market. And typically that first valley of death, or the first hurdle, occurs around that preclinical translation phase when products are trying to get into the clinic. And you'll probably hear a little bit more about that tomorrow from Jamie Trickus in his talk. But with vaccines, the valley of death is actually deeper and more problematic than it is with many other health technologies, and that's for a few reasons. The costs up front can be quite significant to get into phase 1 clinical trials. That's because of the regulatory and manufacturing complexity that we have with vaccines as compared to small molecules. There are different tensions in the market for vaccines. Typically, it's a single course of vaccines. It's not a chronic treatment that's given week in, week out. Pricing is lower in low and middle income countries. Vaccines are products that have tiered pricing, where they're typically launched at higher prices in high income countries, and then much lower prices in Gavi eligible markets and UNICEF markets. And for some vaccines, we have market failure. So think about epidemics, the story with Ebola, and also vaccines for antimicrobial resistance, where there is simply not enough of an attractive market to really drive the innovation. So across the top, you can see what we call technology readiness levels. One of the other things we decided to do was to look into Australia's history of commercialisation and see how we'd fared. Now, there's not really any globally accepted way to measure translation and commercialisation, but the best framework that we could come up with is the technology readiness levels, which are used by NIH and BARDA, but also used by a number of the grant funding programs here. Now, to add to that funding challenge, this is from a report that was done by BIO, the US Industry Association, and you can see in the purple graph the amount of venture capital that was raised for oncology products compared to infectious disease vaccines. So that's a pretty stark difference. Funding is much harder to raise for infectious disease products. And I've got a question mark on the right for Australia, because whilst we can get some figures about funding of medical research in Australia, what we can't really do is break that down by therapeutic area and know exactly how much is going to innovation in infectious diseases. The data is very fragmented. Now, this slide really was just a comment on what's been presented earlier tonight, that we're now facing even more downward pressure on the funding because of the changes that have been talked about in the US and the fact that they've withdrawn from the World Health Organization, the funding cuts for NIH and BARDA are going to have significant greater impact and uncertainty on infectious disease products. And this has also led to some shift in investment from pharmaceutical companies as well. Now, there is a nice report put out by Impact Global Health that looks at the amount of funding in the Australian landscape for neglected diseases and emerging infectious diseases. And you can see here that malaria dominates, and you can see that the funding for various diseases from 27 to 22. Now, what's interesting about this report is we do slightly better than Canada in our overall funding of global health, but we do worse than New Zealand. But overall, as we know, our proportion of R&D invested in medical research is low. So we tried to have a retrospective look over the last 20 years and say, well, what is all the research that's been funded in Australia, and where are they now? And we did this by trying to interrogate a number of different databases. We looked in the IP database, the patents, and we identified 642 unique patents that were filed for infectious disease products, and so they could be vaccines or other similar technologies to prevent infectious diseases. We then looked in the grants database to see how many of those inventions had gone on to win a grant, and we found 524 grants awarded. But it's not a subset of the 642, and in fact there's no way of linking them. Sometimes the names have changed from the inventor to a university to a company name, and there's really, other than manually sorting, no way to track that translation. We then tried to look at how many products had gone into the clinic and identified 130 clinical trials for vaccines where there was an Australian sponsor, so we excluded trials in Australia from overseas sponsors. But again, that's not a subset of the innovation we saw in the patents or the grants, and in fact it could be a simple duration of immunity study from an Australian sponsor. It might have nothing to do with a new innovation. And of course we know we have Gardasil as the one Australian innovation that is on the NIP. And of course what we were trying to do with this exercise was look at the translation rates that you can see on the bar on the bottom, and they show the typical success rates transitioning from each phase of development all the way through to a biologics license application, which is when you apply for FDA approval. And the global likelihood of approval from phase 1 is only 11%. So it's a challenging job to get a new vaccine all the way to market. The 130, the trials that I showed you are now broken down here, and this is a nice graph I like to show because it just shows you the impact of global events, and in particular SARS-CoV, and you can see the dramatic increase over the last 23 years of clinical trials in Australia for vaccines. And that's important for a couple of reasons. We've separated the graph here into the purple colours are the Australian sponsors, and the orange colours are international, and companies operating here, if they have an overseas headquarter, would be included in the international. And what's interesting is not only to see the growth, but to see the different phases and understand that this also recognises the strong research infrastructure we have in Australia, the fact that so many international companies come here to do clinical trials, often to access R&D tax incentives, but also the great capacity we have to grow the workforce, develop the skills, and attract that overseas investment. So Rod mentioned the Vaccine Value Chain Conference. We held the first one in May 24, and we gathered 215 stakeholders from across the ecosystem. And the idea was really to get industry, academia, government and not-for-profit and healthcare providers all together to identify barriers and opportunities right along the vaccine value chain. And one of the calls from that conference was that we really should develop an Australian public-private partnership to support vaccine development. And it's interesting when you think of all the NGOs and PPPs that you know that support vaccine development. I can't find one yet. I'm happy to be corrected in the Southern Hemisphere. They're all in the north. So if you're interested in the report from that conference, you can find it online. We came up with a series, the community came up with a series of 17 recommendations, really driving a national approach, investing in prevention and the full value of vaccines, enabling new policy and regulatory pathways, and of course, strong community engagement all the way along the value chain. Now, while we were busy delivering the conference, the Medical Research Future Fund issued a new grant opportunity for a biomedtech incubator. And we were very fortunate with the timing because we had the whole vaccine community, I guess, with us at the conference, and we were able to put in an application, and very fortunate to be awarded one of 3 grants of 32.9 million to set up a national virtual vaccine incubator, which is called BioIntellect Ventura. And this was launched late last year with the expressions of interest opening on the 17th of November. Now, in order to get prepared for the launch, we also wanted to understand how many people might apply, or how many technologies might apply. So we've done some further mapping of the Australian landscape, and we identified 58 technologies that were mostly in the preclinical stage, and you can see it's broken down into about 40 vaccines, about 10 immunotherapies, and 8 platform technologies. And you can see the split there of the different pathogens that they're targeting. Most of them are preclinical, about 2/3, with about 1/3 already at clinical stage. One of the features of the MRFF grant is that you have to be an SME, a small medium enterprise, to apply. So you have to have spun out of university and created a company. So then we tried to map the landscape of companies that we could identify. And we found 15. In fact, there's a few more. But all of this work was just done with desktop research. It's not published, although we'd like to build upon it and do so. But it did give us a snapshot. And in the end, our EOI closed in December, and we actually had 48 applicants for funding from BioIntellect Ventura. So what is BioIntellect Ventura? So our tagline is accelerating Australian vaccine and infectious disease innovation for global impact. And our mission is to nurture promising early stage companies by providing the funding, the access to expertise, and the resources to accelerate the development and commercialisation of their new technologies. And our future vision is really to establish a sustainable and diversified funding model for infectious disease innovation so that we can have a world-leading incubator that's available in the long term. A quick summary of the sort of grant opportunity and the eligibility rules. We have just 7.9 million over 4 years to set up and run the incubator and access all the expertise that we need to nurture these companies. And we will be giving away $25 million in non-dilutive funding to people that successfully apply. We expect to have about 3 cohorts over the 4-year period who'll get funding for up to 2 years, and each company can apply for up to 5 million. And in our first round, we allowed people to apply for 1.5 million if they were at technology readiness level 3 to 4, and up to 3 million if they were 5 to 6. And there'll be an opportunity for them to come back and apply for top-up funding based on successful milestones. And then one of the other things we will do is provide masterclasses, hands-on support, and there's a number of people in the room that will help us and provide their expertise to do that so that these companies can get access to the right mentoring and support for their technologies. We have a robust governance model that's set up. BioIntellect's a private company, but we have a steering committee that's chaired by Trent Munro at the University of Queensland and has multidisciplinary and multi-jurisdictional representatives. We have 2 advisory bodies, funding and investment, and a consumer advisory group, which is led by Margie Danchin at Murdoch Children's Research Institute. And we have a panel of experts who have been generously giving their time to review the applications, who form the Investment Review Committee, and that's headed up by Erica Knipe from CSIRO. And then on the right-hand side, we have our operational team in BioIntellect Ventura who are executing on this exciting new opportunity. And of course, I talked about the broken business model for some infectious disease products. And when you think about the future state, the funding for infectious disease innovation really comes from many different sources. So it may come from industry, which could be from the private sector, it may be the pharmaceutical industry, it may be venture capital, or it may be for global health and come from Wellcome Trust, Gates and Gavi, or even for outbreaks, organisations like CEPI and BARDA. So when we think about our future state, we really envisage biointellect venture as sort of being having potential funding from all of these sources for the future, so that we have a sustainable model in 4 years' time at the conclusion of the MRFF funding. The initiatives of biointellect venture are very much aligned with the national science and research priority. So they support the ability for us to drive local innovation to help respond to future pandemics, but also to underpin a secure and resilient supply chain all along the value chain, and hopefully have real health impact by translating these technologies. It's also very consistent with the National Immunisation Strategy, their objective number 5, to harness new technologies, and we've had some great engagement with the department to make sure that we get input from government around their priorities. So they say it takes a village to raise a child. Our last one just left home yesterday. It takes a whole ecosystem to commercialise infectious disease innovation, and we couldn't have done it without most of the logos on this slide who've been behind us on this journey to create this value chain community and support our application to the MRFF. We will be holding another conference. These leaflets will be available tomorrow with the save the date and a bit of information for the conference on the back, and you can scan the QR code and sign up if you're interested. And finally, just a thanks to all of our supporters who helped us on the journey to get this far. Thank you.
So just before I ask Lou to come and wrap up the day, some questions, but thank you, Jenny. It's John.
Jen, a great synopsis, and you brought many elements together. Having been a fan of history and occasionally listening to Geoffrey Blaney, my understanding is the first reference to the value of death was Alfred Lord Tennyson in The Charge of the Light Brigade. So sometimes we need to learn from history. There may not be much that you can learn from all of that, but in kind of going forward, and in the current context when Vic Health, which has been a fabulous institution promoting health promotion, is kind of under siege, a lot of things you're doing would be very relevant in a lot of areas that they're doing beyond vaccines. So there are a lot of other players out there. Prevention's really hard to get a support, and implementation, as you know from my background, is the hardest element. You know, it's kind of, if you don't get that right, all of that other work going beforehand doesn't work. So worthwhile thinking about the history, and the Vic Health people, have been some terrific people in there who will have lots of good ideas that can kind of say, how might this work in other areas? So you get a good groundswell of support.
Yeah, well, thank you, John. Michael and I were trying to find a military reference earlier, weren't we? So we've got one now.
I can't vouch it's the earliest.
I shall look it up.
Tennyson's poem was 1854 in the Crimean War, which is, a lot of people are thinking about all that stuff which is not related to tonight. But anyway,
Crimean War. Yeah. Right. So Jenny, I think thank you for a whole lot of reasons. It's valued and enjoyed and received with interest. Thank you very much. Yeah.